Keynote address, which is on protecting and improving the critical space infrastructure. Please welcome him.
Hello, so I'm Chris Macintosh, CEO of Methera. Quick history on my background. I've spent the last 7 years as CEO of Methera. Prior to that, I was CEO of Viasat UK. I had a couple of years before that running a cyber startup, which we spun out. And for my sins, I spent 20 years in the British Army prior to that, abusing any form of satellite technology. Can I have a short, brief chat about improving and protecting the critical space infrastructure? And there will be questions, time for questions at the end. At the high level, the message is that the protection of space assets is becoming critical. And in addition, that space situational and domain awareness are most certainly crucial. And during this short talk, I'll explain why at Methera we believe that. Okay, the key components, you can see most of them there. Anything around position, navigation, and timing, i.e. PNT, generally used as satellites. Communications and broadband services, Earth observation, remote sensing, weather, all of the other things that we do from space. And of course, a plethora of defense capabilities, all across what we term as ISTAR, and including missile warning systems. Now, of course, we haven't all of a sudden ended up in the situation we're in, but we are in a day where the number of satellites are growing ridiculously quickly year on year. But more importantly, we are becoming more and more reliant on what satellites do for us. Even though a lot of the time, most people don't even realize that it's got anything to do with satellites when they're utilizing things such as their GPS in a car. And what we do know is that potential adversaries are banking on the fact that if we are denied the services that are provided from space, it will give them a distinct advantage. In addition to this, developments in satellite, not only maneuverability, but their whole fueling system and the way they move, means that satellites do not allow us to just sit and stare from Earth up into space every 2 hours or up into the geobelt, knowing exactly where each satellite's going to be. Because they can now maneuver, which means that when we lose track of where a satellite is, it can take us months, if not longer, to identify where it is and maybe what it's doing and what it's either disrupting or training to disrupt. And of course, going outside the defense and military sphere, we're concerned about space traffic management as the number of satellites increase. And of course, the Achilles heel, debris. And how do we avoid debris and reduce the risk to our assets? So when that's all taken together, what it means is that a domain which has been relatively quiet to date is now becoming an area of concern. And for developed nations, losing the ability to control and own our space assets can significantly disrupt a country's ability not only to defend itself, but to survive. So I'm going to outline a quick overview on what Methera are doing and the system that we're developing, which in essence addresses at a high level some of these threats and reduces the consequences. So the Methera system, and we call the base system the Methera cloud, is all about introducing into MEO at about 20,000 kilometers an infrastructure of MEO satellites with optical inter-satellite links. That mesh network will also have processing and AI on the edge capabilities and Gen 2 storage facilities. And that base infrastructure will allow us to, in essence, plug and play additional services as and when required. Starting off with a small number of satellites in the infrastructure, which would be about 12, and growing up to the 128, which we have filed for. To complement the system, we will also have a number of LEO satellites that will also be interconnected. And the whole idea at this stage is not to produce one type of capability, it's to produce the bedrock for us to be able to deploy a number of capabilities and services over time. At the heart is what we call Espada, and it's the AI engine that allows us to control what's happening in space, to make decisions in space automatically, and, for example, when it comes to something as straightforward as what information is sent down to Earth, make logical and sensible decisions as opposed to basic time event decisions, for example. So to outline the key services that we are introducing to, in essence, help protect our space assets. I'll start with space domain awareness. Space domain, or space situational awareness, is all about the collection of information and intelligence about space. And we're interested in what we can collect from space that is unique. And what we're actually doing by putting satellites into medium Earth orbit, sat between LEO and GEO, that allows us instantly to have a full view of the constellations and of the satellites at GEO 24/7. So the long stare. Also, because we're on 4 different inclined orbits, it means that we've got slow-moving satellites in MEO that can observe different areas of space. And in essence, we end up with a 4D stroke 5-dimensional image stroke information about what's going on. And when you think about it, trying to look at objects in space from Earth, which is what we do right now, there are a few big problems. Firstly, there's the solar exclusion zones. When you're looking with an optical sensor from Earth out towards a target, whether it be at LEO or at GEO, if the sun is behind the target, you can't see it because the sun will blind your optics. If the sun is behind the Earth, you can't see it because it's in the dark. And what that means when we talk about the solar exclusion zone is that hostile nations who wish to interfere with our space assets will clearly do those things during times when they know that we cannot see them. So by putting sensors out into MEO, that gives us a different angle at the target areas. And therefore we shrink right down that solar exclusion zone. So that's one part of it. The other part, of course, is not only that we're sat between those 2 major conurbations of satellites, it's the fact that we can choose the sensors. So optical will be one, but of course we can put active sensors on our satellites as well. And what that allows us to do, in essence, is to completely mitigate the fact that there are times when the sun might be behind the target or behind you. So the Space Domain Awareness service is principled on the fact that we're in a great position to maintain custody of targets 24/7, that we can collect unique data when others cannot see those targets. And of course, since we start off with an initial constellation and we then deploy additional satellites a couple every year, it allows us to introduce new capabilities, new sensors over time. The second thing, and second service we're looking at, is satellite data relay. And satellite data relay, in essence, what we're looking at is sat between LEO and GEO, allow LEOs to send their output up to MEO, and then we can ground or earth that information anywhere on Earth, because all of our satellites have got a link down to Earth, and they're all interlinked with inter-satellite links. So what that means is that the LEOs that some people currently consider will be very vulnerable during a major operation or campaign with certain countries, and might actually be destroyed to different degrees after a major incident, which could be an accident. By having multiple routes, that allows you in essence to continue to operate whilst the LEO orbit degraded over time, and or if there were incidents, stroke events on Earth, such as the cutting of fibres, cables, etc. And then hosted payloads, which we're doing very much for ourselves, allow us to have a standard swap, size, weight, and performance and power for hosted payloads to actually be added to our constellation. So we can host not only our own payloads, but we can host other people's payloads because they know the actual constraints, dimensions, etc. that they have to work to. And finally, dynamic broadband, the ability to provide small spots of broadband anywhere on Earth at practically real time. And that, as far as we're concerned, closes the loop so that information and data that's collected in space can be earthed when it's required, and we can have two-way communication from space to the ground, or even using the data relay service from GEO down to MEO, either back up to another GEO or down to a LEO. All routes being supported. There's a quick summary of the dynamic broadband service, based very much on providing beams 150 diameters wide, 20 gigabits per beam, down to any spot on the Earth. Of course, we're limited in the number of spots we can provide on the Earth, but we can move them anywhere. And space domain awareness, the unique point that comes out from it is being able to collect data on man-made, i.e. satellites, spacecraft, or debris that is unique and cannot be collected by currently any other systems. Satellite data relay, of course, it's not a new topic. It's not something which people have only just started considering. But the difference of what we're going to actually deliver is a data relay service. Of course, it will be end-to-end, but it will be very much an ad hoc make-before-break system. And what that means, in essence, is that other constellation, other providers will be able to carry our packages which allow them to become part of the network. A bit like the way you have a self-forming network that's mobile on the ground, we're moving that technology up into space. So even though we won't have satellites in GEO, or there are no plans currently for us to put satellites into GEO, The plan is very much that other operators will allow us to put our sensors onto their satellites, which will allow them to then become part of the data relay system. And of course, payload hosting, which allows us to put up further services quickly. But most importantly of all, we end up with an infrastructure that allows us to, in essence, deploy new services and capabilities cheaper, i.e. more cost effectively, and quicker than we would be able to without it. Okay, conclusion, the summary. Space assets are becoming increasingly vulnerable. Whilst as far as the developed world is concerned, they're becoming increasingly important. It wasn't that long ago that space or satellite broadband was considered as a choice of last resort. It's now normal business. In fact, a lot of people don't even realise when they're using space or when they're using satellite broadband or satellite communications. It's become the norm. If we lose it, it will significantly spoil our day. And the key components for protecting it as far as Methera are concerned: delivering information, intelligence and insights on activities in space, whether they be things that have been done on purpose, accidents, or things that are totally out of our control. And providing a platform that in essence accelerates the delivery of space-based capabilities. And as I mentioned, Edge AI is not just a buzzword. The amount of data that is collected and utilised in space means that we cannot afford to send all that data down to Earth to be processed. We need, in order to react at the speed we have to be able to process that data in space. And finally, delivery of an on-demand, resilient satellite data relay service and broadband service is at the heart of what we do. That's it from me. Are there any questions, please?
Hi, just one question I have. You said you will put sensor on satellite. So if suppose satellite is already in the orbit, then how will you put the sensor?
Sorry, could you say that again a little bit slower? I'm English, so I have the worst English here.
So you said that you'll put sensor on satellite, right? But if satellite is already in the orbit.
Okay, so when I said that we can grow the network for data relay, what I'm saying is by defining the system now, therefore what our sensors and our relays are going to look like and what's required to join the network, that means that operators will be able to make the decision now that future satellites will carry those equipments. And that's why it's all about starting the partnership and people understanding that it takes more than one company to produce the type of service that we're trying to do.
So it's for the new satellite, right?
Thank you.
I've got a question. You spoke about the inter-satellite relays and the inter-satellite communication. I just wanted to clarify my mind. Are we talking about data, that is the raw data, from a low Earth orbit satellite to a medium Earth orbit satellite, or is just the telemetry commands?
We are certainly talking about the data that's been collected, i.e. the product.
Okay, thanks.
Just adding on to his question, so are these optical data links or they are RF links?
Optical data.
Okay.
Coming on to the satellite, inter-satellite links, which we feel is the mother layer for your performance. Could you please explain the performance metric and the security features for this link?
I certainly am not going to define now the details of the OSILs, and I'm going to say the maths behind the spectrum, etc. I won't do that in this audience. Happy to take it offline.
Will it be possible to mount customizable user-designed, user-specific encryption systems on this laser optics?
Yeah, I'm happy to take that offline. Well, thank you very much.
Thank you so much.